Assalamualaikum and hi to all. So this is a lecture of BMCT 3143 Heat and Mass Transfer for the topic of force convection for external flow. So in the convection heat transfer, there is three convection, which is free convection, force convection, and convection with phase change. For free convection by buoyancy force, force convection by pump or fan, and convection with phase change is by boiling and condensation. For force convection, there is an external flow and internal flow, and in this video I will give the introduction of the external flow. So force convection, external, introduction to external flow, and in this lecture I'm going to cover the parallel flow over the flat plates, flow across cylinder and sphere, flow across tube banks. So for this first video, I'm going to give the introduction to external flow. So we start with the drag and heat transfer in external flow. So fluid flow over solid bodies is responsible for numerous physical phenomena such as drag force, lift force. So as you can see in the figure, aeroplane, house and wind turbine. So for the aeroplane and wind turbine, drag force and lift force is generated from the fluid flow over it. Whereas for the house, only drag force generated from it. So this fluid flow can be used as a cooling purpose of metal or plastic sheet. So in this fluid flow, there is free stream velocity, the velocity of the fluid relative to an immersed solid body, sufficiently far from the body. As you can see on your right hand side, top figure, free stream velocity, solid body sufficiently far. So there is no disturbance to the velocity of the fluid. So this is called the free stream velocity. And the next one, the fluid velocity ranges from 0 at the surface, the no slip condition, to the free stream value away from the surface. And as you can see on your right hand side, bottom figure, so the dotted line is the separation line from the variation of velocity and the free stream velocity. So I put it here as the below dotted line and above dotted line for your reference. And the below dotted line is the value of the velocity varies from 0 to certain value, whereas above the dotted line, the value of the velocity is almost equal to the free stream velocity, or not almost, it's equal to the free stream velocity, and it is called as the free stream velocity. So friction and pressure drag. The force a flowing fluid exerts on a body in the flow direction is called drag. And you can see in the automobile, in a wind tunnel, there is a wind blowing over it from the front by 6 miles per hour, and there is a gauge suspended to the front of the automobile, and this force is called the drag force, which is FD in here. So the force which push the automobile backwards is the drag force, and the drag force is composed of pressure drag and also friction drags. So there is two kind of drags that being utilized in this. So on your right hand side again, so the top figure is the friction or screen friction drag, one example of it, and the bottom figure is the pressure drag. So for the screen friction, when the surface same as the flow over a flat surface, there is the velocity is 0 from 0 to certain value. This is dominantly composed of the friction drag or screen friction drag. Whereas for the bottom figure, high pressure, because of the high pressure in front at the front of the wall and low pressure back of the wall, this is dominantly by the pressure drag. And the drag force is depend on the fluid density of the fluid, the upstream velocity, and the shape, size, and rotation of the body. So the dimensionless drag coefficient CD is defined as CD equal to FD divided by 1/2 rho V power of 2 and area. and it mentioned here at low Reynolds number, most drag is due to friction drag. The friction drag is also proportional to the surface area. As you can see in the equation of the CD, FD is directly proportional to the surface area. The pressure drag is proportional to the frontal area and to the difference between the pressure acting on the front and back of the immersed body. So, okay, slide. So the pressure drag is usually dominant for blunt bodies and negligible for streamlined bodies. And this can be explained by the figure on your right hand side. You can see for the flat plate being put horizontally along the streamline, so the drag force is 0% and skin friction force is 100%. So, and you can see in the figure number 3, which is a cylinder, same with the figure in the main text, in the main slide. So the drag force is 90%, roughly 90%, and skin friction is 10%. This is what is being mentioned. The pressure drag is usually dominant for blunt body and negligible for streamlined body. Okay. So the example is from the figure on your right hand side, so the first figure and the third figure. When a fluid separates from a body, it forms a separated region between the body and the fluid stream. The larger the separated region, the larger the pressure drag. So you can see in the figure, the red arrow show the where is the separated region. So, and the wake, after that, after the separated region, there is a wake region, which is the circulation. As you can see on your right hand side, the figure on your right hand side, the cylinder is red in color. So for the figure number 3 and number 4, okay, on your right hand side, so the drag force is larger as compared to the skin friction force. This is what it means by the pressure drag is usually dominant for blunt body and negligible for streamlined body. Okay, heat transfer. The phenomena that affect drag force also affect heat transfer. Why? Because the local drag and convection coefficient vary along the surface as a result of the changes in the velocity boundary layers in the flow direction. So it reflects almost similar parameter. So the average friction and convection coefficient for the entire space can be determined by CD equal to 1 over L integration L over 0 CD dx, and for convection H equal to 1 over L integration L over 0 Hx dx. So it shows almost similar equation. So that's all for this part of my video. Thank you. Hope you enjoy this video and good luck for your study.